Now, question 1.4, we're going to have a look at South African Berg winds. Okay. Now, a very popular question regarding climate. Okay. When do we experience this type of climatic conditions? Winter, where we are situated now. Now, if you look at today, if you look at the beautiful, I want you to do yourself a favor. Instead of stalking all your mates on Facebook, go to Southern African Weather Today, okay, on Facebook. Brilliant. It shows you a synoptic chart by a guy called Mike Perich. Absolutely brilliant. It shows you a daily synoptic chart. Now, unfortunately, I can't load it on here, but the beautiful example of Berg winds conditions being experienced today in the Western Cape. Okay, we experience these Berg winds only during winter. Now, let's just go back to my diagram. Let's just quickly have a look at the name. Berg winds. Berg is the Afrikaans term for mountain. Okay. So basically, we can always mention them mountain winds. Okay. But very interestingly, when we look at our figure 1.4, pay attention to the following. We have the Kalahari high pressure system present. Okay. Very important grade 12s. By now, with your general knowledge that you've basically have learned from the climatology, we only experience the Kalahari high pressure during winter. Okay, could quickly draw roughly, just a roughly synoptic chart showing what happened. Winter conditions. Okay, if that's South Africa, right, we are situated on a 30-degree latitude. So, we have three high pressure systems. The South Atlantic high pressure, the South Indian high pressure system, and then in winter, what is present? Over the interior, the Kalahari high pressure system. Okay, keep in mind, when we look at the high pressure systems, what do we know about high pressure systems? It's sinking air, subsidence taking place. What's the circulation in the summer hemisphere? Anti-clockwise circulation. Very important. Okay. So we know it's winter, if we go back to our diagram, because this Kalahari high pressure system is present. So let's just make a couple of errors here. I just want to clean my diagram over here quickly. Remember, the term Berg winds is known as mountains. So it's basically air moving down to mountains. But let's just go back to our diagram. So we got the Kalahari high pressure system over here. Remember, we got sinking air. That's what's taking place. Okay. Sinking air, subsidence taking place because of the Kalahari high pressure system. Then we have the Central Plateau. This is inland to South Africa, Gauteng, Free State, the Northwest. Over here, this bulge that you see over here is known as the Escarpment. Now, from South African point of view, what I tried to show you, I'm going to show you over here. This is the coastline. Let's assume this is where Durban is, this is where Cape Town is, and this is Joburg is situated over here. We have a mountain range, significantly to South Africa, known as the Escarpment, the Drakensberg Mountains, the Maluti Mountains, all down to Cape Town. And the high-lying area over here is known as the Plateau. Now, basically what happens over here with Berg winds, we experience during winter because we had the Kalahari high pressure system over the interior of South Africa. Now, when we experience these Berg wind conditions, it might be because there's something next to the coast taking place. Now, the first basics we need to go back to. How does air move? Air moves from a high pressure to a low pressure. And that is known as winds. Am I correct? So, we already established Berg. It's a mountain. But now we need to find out, listen, there's winds. Define winds. If you need to tell someone what's winds, it's when air moves from the high pressure to the low pressure. So what did we identify? If we go back to our diagram, we have identified our high pressure. Now, where's our low pressure? It's usually next to the coast. So if I go down to the bottom diagram that I've drawn, sometimes we experience a coastal low pressure. Okay. A coastal low pressure. So it moves from east to west, all along the coast, as you can see. Okay, so it moves from east to west. Now, it's very simple. The name actually tells you exactly what it is. It's a coastal low pressure. What is it? It's a low pressure that forms at the coastline. Okay, simple as that. So we have our coastal low pressure. What's the circulation of air in the coastal low pressure? Clockwise. Now, very importantly over here, grade 12s, that I need to share with you. Okay. Because of this clockwise circulation of our coastal low pressure, we experience different types of flow. Okay. First of all, because of the clockwise circulation, I just want to make a little A over here. What flow will be experienced where A is? Onshore flow. Okay. Why onshore flow? Because of the circulation of air in the low pressure system, where is the air coming in? Because of the clockwise circulation, it's coming onshore. So it comes from the coastal regions. But on the opposite side of the coastal low pressure, what type of flow are we going to experience over here? Offshore flow. Okay, because where's the air coming from? Because of the clockwise circulation in this low pressure system, it goes inland towards the coast. Now that's a coastal low pressure, like the name indicates. Now let's just go back to our top diagram. They've mentioned warm offshore winds taking place. And they've given us a tip as well. I just want to clean my diagram a little bit over here. They gave us temperature. Okay. Temperature over here represents 14 degrees Celsius. But on the other side of the escarpment represents 26 degrees Celsius. And they've mentioned warm onshore winds. Okay, offshore winds, apologies. So basically what happens, if you go back to my beautiful drawing, just kidding, no, it's not beautiful, but if we just have a look at this quickly. So we have a Kalahari high pressure system over here. It's on the top of the plateau, and we have a coastal low pressure over here. Mind you, I forgot to mention that we can even have a mid-latitude cyclone passing, okay, with the cold front, okay, moving also west to east. So mid-latitude cyclone also presents a low pressure, and air moves from a high pressure to a low pressure. But let's just stick to the coastal low pressure. Going back to my diagram, how does air move? From the Kalahari high pressure system to the coastal low pressure system. That, grade 12, is known as wind. Okay, if you need to define wind, so when air moves from a high pressure to a low pressure, simple as that, done. Okay, so if we got a high pressure over the interior, it's moving down the escarpment, down to the coastal low pressure. Now we got winds. Now we're going back, so what happens? The air moves from this high pressure, as the arrows indicates, over the escarpment, down to the coastline. Now, because there's a high pressure and there's a low pressure at the coastline, coastal low or mid-latitude cyclone. But what happens over here, grade 12s? We have an increase of temperature. All of a sudden, we experience an increase of temperature because on top of the escarpment, as you can see, we experience 14 degrees Celsius. But as it moves over the escarpment, it warms up to 26 degrees Celsius. Okay. So what do we call that term? You've learned about this before in grade 10. The air heats up adiabatically. That's the correct term that we use. So I'm going to give you a simple scenario. Okay. And it's very simple. Let's say we go for a geography field trip. Okay. There's Mount Kilimanjaro. Remember, the rule of thumb is the following. For every 100 meters we increase with altitude, what happens? The temperature decreases by 1 degree Celsius. Okay. The temperature decreases with 1 degree Celsius. Okay. Now, if we go 200 meters up in altitude, it's going to be 2 degrees Celsius colder. Simple as that. Okay. When you go and climb Kilimanjaro, you're not going to end up in your board shorts and bikini up there, are they? No. You're going to be stocked in Cape Union clothing. It's going to be ice cold over there. Now imagine you're climbing down from the summit. What's going to happen with the temperature? It's going to increase. So this is what's happening with this Berg winds over here, grade 12s. So we're moving from the top of the escarpment down the escarpment, right? So we're climbing down Kilimanjaro. We can almost say down, if I use Kilimanjaro as an example. So what's going to happen with the temperature? It's going to warm up. So remember, the rule of thumb is for every single 100 meters, the temperature usually decreases with a degree Celsius. But now we're going down. So eventually what's going to happen for every 100 meters we're moving down? Temperature will increase. Okay. So what happens over here? As the air moves down the escarpment, it warms up. For every 100 meters, it goes down, it gets 1 degree warmer. Okay. Now, in general, Johannesburg, just want to get my pen out. In general, Johannesburg is 1,600 meters above sea level. And let's assume this is down to Durban. So as you can see, the temperatures should be roughly, as you move down, get 16 degrees warmer. That's what's happening over there. Because we're moving from a high altitude to a low altitude. Okay, so that's Berg winds. Let's just quickly go over this. Berg winds, mountain winds. Okay, what's winds? When it moves from a high pressure to a low pressure. Okay, it's mountain winds, it's Berg winds, is coming down from a mountain. What do we call this mountain? It's basically the escarpment. We need two things that's present. We need the high pressure over the interior, known as the Kalahari high pressure. When do we experience the Kalahari high pressure? Only during winter. Okay. Coastal low pressure or mid-latitude cyclone. The air moves from a high altitude to a low altitude. It warms up, heats up adiabatically. So we experience warmer conditions at the coastline. Okay. Let's go and look at the questions that's being asked. Now, like I said, I hope all of you do get a copy or have a copy of this question paper so you can follow and make notes as you continue. Now, study figure 1.4 based on the South African Berg wind. And the first question, we just studied it. I explained the Berg wind condition to you. Name the season in which South African Berg winds develop. Very simple. The correct answer over there is going to be winter, because what do we have over here? We have the Kalahari high pressure system. So I'm just going to write the answers down there at the bottom. So question 4.1, the correct answer will be winter. Okay. If we just quickly have a look at our next question states 1.4.2. Give two pieces of evidence in figure 1.4 to support your answer to question 1.4.1. Now, let's go back to our diagram. As you can see, let me just quickly clean up a little bit over here. And then I'm just going to write the answer over here. Give me two pieces of evidence to support that it's winter. Okay. First of all, I mentioned to you, look at the Kalahari high pressure system is situated over there. The second reason, look at the temperature, 14 degrees Celsius. Kind of think of it, that's what we've been experiencing for the last couple of weeks. We experienced frost in the mornings. Why frost? Because we got clear blue skies. We got clear blue skies during the day as well because of the Kalahari high pressure system. But maximum temperature up here in Johannesburg is roughly 14, 13 degrees daily. So our first answer we can write there is the Kalahari high pressure. We have 14 degrees temperature over there. And we're experiencing offshore flow of warm winds. Okay, let's just write it down. for the learners at home copying this down. So what's the reason that we can say it's winter? We have the Kalahari high pressure system present. Okay, there's a low temperature of 14 degrees in the interior. Okay, and I've mentioned this movement of air from the Kalahari, I'm just going to write today, KHM, towards the ocean. Okay. Now let's just quickly have a look at question 1.4.3. Now if you have a look at 1.4.3a, why are Berg winds described as being dry winds? Okay. Simple reason, I've explained it to you in this diagram over here. If you just have a look over here, let me explain it to you. It's dry because it's offshore. Okay. Completely different story when we're experiencing onshore winds. When we experience onshore winds, air that comes onto the shore, onto the coastline from the ocean, there's going to be water vapor. There's going to be water moisture content in it. Now, these offshore winds come from a continental point of view. In grade 10, you've learned about two different climates. We talk about continental climate and maritime climate. Okay. I just want you to wrap your heads around this quickly. Now, offshore flow winds comes from continents. There's not much water surfaces, so it's going to be much drier. Okay. If we look at this diagram over here, I just want to redraw this quickly. Okay. Just hang on, let me just draw a brand new one. Keep in mind the air comes from inland. Now, when we look at this diagram, remember, excuse my beautiful South Africa, but we have the Kalahari over here, and we have our coastal low pressure over here. So the air moves from the Kalahari high pressure to the low pressure. Okay. Now remember of the circulation of air, anti-clockwise, clockwise for the low pressure system. So we're experiencing offshore winds. So it's much drier. So if we're just going to write the answer, the correct answer that we can write there, 4.3a, we can mention that as the air descends, it loses moisture. And we can also mention, it's just a one answer question, but we can also mention there's little moisture in the interior. And lastly, so you can mention any one of these, but like I've just explained to you, the most important answer for me is to describe it. They originate from land. Different story if the wind was blowing from the ocean's direction. Okay. Now, if you quickly look at question B, what causes the South African Berg wind to be a very warm offshore wind? Now, I've explained it to you. It's the adiabatic movement of air from a high altitude to a low altitude. If you go back to our diagram that's been provided for us, I'm just going to look at this diagram. So the air comes from the Kalahari high pressure system that sinks. It moves down the escarpment. What do we say? Because every single 100 meters it moves down in altitude, the temperature rises with 1 degree Celsius. And the term we use it, why is it so warm? Because it warms up adiabatically. That's the correct term. So let's just write it down there. Okay, the air heats up adiabatically. Okay, and I just want to write it there for your own notes at home. The temperature rises 1 degree Celsius for every 100 meters it descends down the escarpment. Okay, now, if we just quickly have a look at question 1.3c, how does the steep pressure gradient influence South Africa's berg winds? Okay, so nice question. It's kind of test a few. It tests your grade 11 knowledge when you've learned about pressure gradient force, PGF. Very simple. I just quickly explain it to you. Very similar as the concept that you've learned in map work in grade 10, and this is obviously grade 11 work. What did we learn? When isobars are close to one another, it's going to be strong winds. When isobars are far from one another, it's going to be gentle winds. So, if the isobars are close, we have a strong pressure gradient. So I'm just going to write there, the winds are going to blow very fast. If the isobars are far from one another, we say it's a gentle pressure gradient. Now, what I've explained to you, let's just have a look at the question. The question asked, how does the steep pressure gradient influence South African berg winds? It's going to have a massive influence. If the pressure gradient is steep, we're going to experience very strong, excessively warm berg winds. So let's just write the answer down there. C, it will result in a rapid or strong wind, and it's going to increase the speed of the wind. Okay, you can also mention the air will heat up very quickly. Okay, now our final question regarding berg winds, and the question states, why are emergency services like ambulances, traffic police on a high alert, standby when berg wind conditions take place? Now, why is it a risk? That's the question you need to ask yourself. Why is it such a big risk? Why do we need to get the ambulance on alert, especially the fire brigade as well, and police officers as well? Now, going back, I want you to have a look at our diagram. The reason for it is because when we experience berg winds, I want you to pay attention to it tomorrow on your way to school. Okay, look at the vegetation. Now, the majority of South Africa, except for the southwestern Cape, okay, Western Cape, experience Mediterranean rainfall. Not Mediterranean rainfall, Mediterranean climate. So the Western Cape receives much of the much needed rainfall now. But the rest of the country, that's why I want you to go and pay attention to. Go and have a look at the vegetation. It's very dry. Okay, we don't receive any rainfall in winter. Our soils are dry, our vegetation is dry, so we are prone to veld fires. Okay, if we do experience, let's say for instance, a veld fire, and Berg wind conditions exist or consist over the next couple of days, it can cause massive, massive havoc. So it will make veld fires basically uncontrollable. Okay. It means, besides for that, even for, I mean, if you look at the temperature differences, 14 to 26 degrees, it makes it really uncomfortable for people living there next to the coast. Extremely warm conditions, dry conditions. It can't be good for crops, especially for farmers. It can't be. There's a risk of veld fires destroying the crops. So nothing about this Berg winds is an advantage for communities or farm people. So what can we write about it? Right? Let me just repeat my question again. Why are emergency services placed on high alert, banzai, when Berg winds conditions occur? So we can write down there 1.4.4. It dries out crop, or it can even destroy crops. Okay, what else can we write? We can also mention there's a possibility, the possibility for veld fires. No, that fires can spread quickly. And we can also mention these fires can harm people and also animals. And lastly, on a hygiene point of view, high temperatures can cause hydration issues. Okay, I just want to add with the fires, because that's our biggest concern when we look at Berg winds. The veld fires may cause visibility issues for motorists. Okay. Okay, and that's Berg winds.